Welcome to the December 16th, 2019 Kubernetes SIG Apps. I will go ahead and share the agenda and notes into chat here for everybody to follow along at home. I think the one announcement that we have is that due to the holiday season, well, there's low turnout for this meeting today, and we are not meeting again in 2 weeks. Just due to the proximity of holidays and so many folks not being around. So that's the one announcement. Did anybody have any other announcements? All right, perfect. Then we can jump right into the discussion. And the very first thing, Chris, I see you're on. You wanted to talk about KApp Nav. I think that's the application navigator.
Yes, Matt. Hi, this is Chris, and yes, I did want to bring that to the attention of this august body.
Okay, is there something in particular you wanted to discuss about it?
Yeah, actually, I would just like to show you folks what we've been working on, and you know, get your thoughts about what we've got, and we've got maybe a question for you guys as well along the way. So if that would be
Certainly.
okay.
Go ahead. You've got the floor. You can share your screen.
I would like to share a screen. Yeah, and let's get that started. Share desktop. Beg your pardon, I didn't think that I would need to take care of this in advance, and I've got to grant permission. Sorry, Matt, just take a second. I'm in that awkward position of doing a first time share through Zoom.
Okay.
I've been Mr. Fly on the Wall most of the time here.
Yeah.
Apps. Zoom. Okay, and I think that it will. Okay, on this end, it looks like we're sharing. Do you see a share for me? And you see a GitHub repo for KApp?
Yep.
Wonderful.
See it.
Okay, so some quick background on this. About a year or so ago, so first of all, my name is Chris Vignola. I work for the IBM Corporation, and we have been doing a lot of work on with the Kubernetes platform in the last couple of years or so, like so many other vendors in the industry. And for some of the customer use cases that we were interested in addressing for our customer set, we observed that the need for an application concept to provide some aggregation of resources and provide a higher level abstraction for users to interact with their applications on the Kubernetes platform would be a good thing. And right about the time we started to do that, we came upon the application CRD that this body had created, and it looked just like what we needed. And so rather than invent something on our own, we opted to use the application CRD for what we were doing. And we started it, you know, IBM has a mixed record of doing open source and and proprietary, and while there are a number of things like Eclipse and things like that that we've done in the open, this was something that we started not in the open. And as we moved along with it, it occurred to us it would be, you know, much smarter to do this piece of work in the open. And so we've moved it to the open, and it's out on GitHub. It's called KApp Nav. And so I wanted to show you what we've done with the application, with the use of the application CRD, just to kind of get your guys' thoughts on, is this interesting beyond, what IBM created for its own self-interest initially? Does it have any utility beyond that? And if so, we'd like to talk to y'all about that further. We're interested in your reaction generally, regardless of whether there's, a broader applicability for this code. And let me start with just, I've got 2 slides and I'll show you a demo. Okay, so just architecturally, UI based interface, of course, and we've got two pods, 3 containers essentially. So there's a UI, there's a backend for front end pattern to facilitate the UI, and those backend APIs happen to be shared by a controller that we wrote. And I wanted to call that out specifically, that we opted to build our own controller because there were some things that we wanted to do that were not in the controller that's in the SIG project. In fact, we started early enough with this that the controller in the SIG project was really just a shell at the time. So we didn't even pick up the shell. We just, we had a shell of our own and we worked from there. I have seen that the application SIG's application controller has evolved since we first looked at it. But we've built a fair amount of code into this one that we've got, and I'll show you what it does. Okay, so let's go and look at the app navigator. We're running this on OpenShift at the moment. So here we see the three pod types that we've got. And did I say 3? Yeah, controller. Oh yeah, we have an operator. I didn't show that on the slide. And then the app navigator itself. So nothing fancy. If you think about the application CRD for a moment, this is probably more or less just what you'd expect. List of applications. This thing called status, I'll explain in a moment. That's a distinctive that we have that's supported by our controller. The skin on this is not the vanilla Kubernetes console skin, but rather open source Carbon components. It reflects the heritage of this code that started out as a proprietary piece of work to be integrated into the IBM cloud experience. So we picked up, while the Carbon components are open source, they're React components. Still, their look and feel makes it look like IBM stuff. We're thinking that we should reskin this and make it look like vanilla Kube, but we haven't gotten to that yet. All right, and so we were going to add an application. We have a sample we like to use called Stock Trader. And what happens is when it gets started, when we add the application, you'll see that Stock Trader is at the top. Its status indicates problem, and that's because the deployments for Stock Trader require 1 replica, and we don't have any replicas yet. So this is a high-level way of the system, of the application navigator, informing that that normal operational status has not been achieved. But you see, even while I was speaking, that the visualization changed. We went from red to green as the pod started, and Stock Trader achieved its operational policy, and then this visualization is alphabetical by name. So once it went into normal state, it got pushed down to the bottom here. Okay, so bubbles up higher level status indicators like you saw a moment ago. Problem got bubbled to the top to try to catch your attention. Okay, now let's drill into Stock Trader first. So if you drill into Stock Trader, what you'll see is a list of components that are gathered together based on the label selector in the application CRD. And so nothing particularly surprising about that either. Now we indicate the, of course, the name, kind, et cetera, of the components that match the label selector as you'd expect. Again, this concept of status, which I will go into in slightly more detail in just a moment. I've got one slide on that, and we'll kind of be done. Repeats here as well. There's an action menu on the side, and I want to tell you about that as well. That's another one of our distinctives here. There's some configurability that I'm going to tell you about. And since it's displayed in front of you, there's an oddity here. What might strike you as an oddity that I want to clarify. This kind, the kind is deployment, right, as opposed to, say, service, and it's suffixed with .liberty. We've devised a convention whereby when it comes to deployments, we add an annotation. We can add an optional annotation that further designates what kind of deployment we're talking about. And that has a relationship to these action menus, which I'll show you in just a moment. Okay, so that's to distinguish say a Liberty deployment, right? That's Open Liberty from openliberty.io. It's some Java stuff. From say a Node.js deployment, from a Ruby deployment, a Golang deployment, or what have you. Okay, and the reason that is useful is because when you consider the two distinctives that KAppNav adds to the general application CRD, we have this concept of a normalized application and component status. Okay, and so we map Kubernetes resource status to a simplified status of green, yellow, and red. And that's to provide kind of a, an easy to view, normalized, high level abstraction of status. And it's calculated by the application controller and it's stored away into the appropriate resources as annotations. Secondly, so that's first distinctive. The second distinctive is configurable action menus. You can think of these as day two operations. These are hierarchical in nature, so they're kind specific. So you can have a set of actions for deployment versus pod versus service versus a custom resource, et cetera. And there's the opportunity also supported for instance level override. So you can actually extend the available actions for a kind at an instance level. So I might have, say, a kind of deployment that has supports specific actions that other deployments do not support. We also use that subkind mechanism where you saw deployment.liberty in a similar way, so that Liberty deployments can have actions that are distinct from Node.js deployments, which are distinct from Ruby deployments, etc. And these are dynamic. They're delivered through config maps. If we were to do this again, and we might make this change anyway, but we delivered these in config maps initially. We weren't too sharp with CRDs when we first started. In hindsight, geez, these probably should have been CRDs, but we didn't do it that way initially. Now, what that amounts to is, if you remember, the Liberty deployment kind had an action menu with 2 items on it, and we can go and add a update the config map that delivers those actions just by updating the config map. I'll refresh the screen to reload the actions. It's dynamic, but it's not that dynamic. And then we see then we have a third action here. Okay, and these action definitions are fairly sophisticated. This one's configured such that it will display an error page for us. Click it. Oops. Sorry. All right, make a liar out of me. I had a pop-up problem with this before. Shoot. All right. The downfall of live demos. I did something wrong here, I guess. No, just got a delayed reaction. My VMs are a little bit underpowered. Sorry about that. So I clicked that action and it took me to this error page. And the reason that it did is because the function is, trying to drive requires Grafana. Darn it. Sorry, I keep clicking. Okay, and so the action as we defined it is designed to recognize when a required capability is or is not present, and when not present, redirect to an error page. And so that's what it did here. Okay, and just to give you a sense of what these actions are like. Okay, so here we have, yeah. So they're delivered in config maps, right? And so we define these actions, and each action has a number of things about it that describe, you know, how to place it into the menu, and then a pattern-driven approach for how to form the URL, right? So we have these substitution operators that we defined that play a role in creating the fully formed. And here's the one that I just added, the fully formed URL. Okay, and so you know, so we have a fairly powerful set of substitution operators that we use to do these, like the ability to drive kube control get, the ability to drive JavaScript snippets to form more complicated URLs, like the Kibana URLs happen to be very complex, and so it helps to have a little bit of programmatic logic available to assemble those. Okay, and really that kind of brings us to the end of the basic story here for what we've done in the way of making use of the application CRD. And so this is you know, an open source project that's out there, and we you know, we're open to you know, community development. There's a CLA to sign and that sort of thing. And that's what we've got, Matt. So we wanted to let you guys know that we've made use of something that you've built and that we've extended in a particular way. And yeah, that's our story.
Okay, thank you for sharing. I don't know about others, but I have a list of questions here.
I figured you probably would, and others might as well. So let's go. Fire away.
Did anybody else have any questions before I got started? All right, perfect. You talked about the controller and how you started it beforehand. I was curious what features you have built into your controller and if it's documented anywhere.
So yes, what we did build into the controller is primarily two capabilities. First capability is this matter of calculating this so-called, we refer to it as a normalized status, where regardless of the resource kind, right, each resource kind has, you know, its own definition of status. We map that to a red, yellow, green, normal, problem warning, normal rendering, and then roll the component level of that up to the application level, okay, to provide a high-level visualization of, you know, is my application working as expected, or is it experiencing some type of problem, okay? And so, like with the action menus, Matt, we use config maps to define those mappings to make it easy to extend to other types, especially custom types. So for example, with a deployment, the way that we map the status is we use a little piece of JavaScript, and we consume the resources status object, and we just interrogate it, and then based on the relationship of the way we chose to define this, right, and a user could override this. We chose to make the relationship between replicas and requested replicas and available replicas the basis for how we rendered the status mapping, okay, of warning, normal, or problem. Okay, so that could be reconfigured,
Okay. Yeah.
right? If you didn't like, our notion of what constitutes, normal, you could override it. Okay.
So the algorithm is written in JavaScript?
Yes, and it's delivered in a config map. Okay, and so we dynamically grab that, right? We did it that way so that you could, we'd have a way to both override pre-built mappings as well as provide mappings for new kinds. If as CRDs are added, additional config maps could be delivered by the CRD owner, for example, to define the status mapping. And we have a default mapping that covers everybody, but it's a pretty ignorant mapping for any resource that doesn't provide an explicit mapping that's based on, right? We just name a convention here just to designate what kind. So this is the mapping for the deployment kind. All right. So if there's a resource kind that doesn't have a mapping, we have a default mapping that we use for that.
Okay. That makes sense.
Unregistered is what we do. Okay, we use that mapping. Now the second, so you asked about the controller. That's the first thing that it does, is it does this status calculation based on these maps, and then it rolls up the components of an application. Their status is rolled up to produce the status for the application itself. And basically, it's the most severe status of a component is rolled up to become the status of the application. So for example, if any component of stock trader was red, stock trader would show as red. Same, yellow. And then when everything is well, if all the components are green, then the application shows as green, or normal. Okay. The second thing that we did in the controller is we were concerned about the application development tasks that the application CRD requires. It requires you to explicitly think about it and create one. And working with some of our developer-facing teams, we concluded that it would be advantageous to make it possible to automatically create an application instance based on some simple metadata that you could that you could affix to standard Kubernetes resources. And so the way we did that, Matt, was we created a label called kappnav.autocreate, and we chose to support it initially on the deployment and stateful set kinds, figuring that those are the typical resource kinds that are used to deliver running code. Okay, and that what we then do is when the controller sees a deployment or stateful set that has that label, it goes and it automatically creates an application instance, and then there are some defaults regarding the label matching that the name of the application, it defaults to the deployment name. It defaults a label selector. All of that's overridable. It defaults a component kinds list. All of that's overridable. And so we've seen certain operators that deploy applications, and they'll typically deploy out like a deployment, a service, an ingress, or maybe a config map, or what have you, right? A set of resources that are part of that, that overall deployment. And so we've got a couple of cases. Our best example is the Open Liberty operator from OpenLiberty.io that has a predictable labeling scheme that it uses. Uses the app label on all the resources that it creates. It sets the deployment name as the app label value on all those resources. And so that's a case where we updated that open source project to auto create the application, to specify the application, auto create label. And it also nicely deals with the case of handling whether or not the application CRD is even installed on the system, right?
Okay. No, yeah, no, and this makes sense. So, being able to actually have interfaces like this and do these kinds of things, when Antoine, who originally was one of the people who conceived the whole application CRD a few years ago, being able to do this kind of thing was one of the things he envisioned. Being able to visualize it, install it, you do things in different ways and different tools interacting, being able to build more complicated UIs on it. This was some of the stuff that he envisioned. So I appreciate seeing it. When it comes to installing this system, is the idea that the user would be a cluster administrator, or could it just be a developer working in the cluster? Is this cluster-wide where different departments may say, I want to use it, and a different one doesn't who may use the same cluster? Or is this kind of meant to be a cluster-wide install tool?
Yeah, that's a great question, Matt. So we've built it so that while it requires cluster admin authority to install, you can install as many instances of it as you like. And we did, you asked about the controller, right? So yeah, now you're tweaking my memory. So one of the things that we did along the way was not only support it as a namespaced deployment, but so it's not right. It's not a cluster scope thing, but also make it possible to specify to partition each instance of the app navigator such that that each instance has a set of namespaces that it sees. Okay, so you can partition the cluster up team-wise, so that Team A's namespaces versus Team B's versus Team C's, and each team could have its own app navigator. So we did build that in as well. Another thing regarding namespaces that we did along the way, Matt, was by default the app navigator looks for components for an application only in the same namespace as the application itself. The more that we've worked with clients doing microservice-based cloud-native type applications and striving to have some number of shared services that they share, not only the code, but the running instance, we saw a need for applications to be able to, by the application owner's choice, reflect as part of the application's set of components, even these shared components that exist in other namespaces. And so we we implemented an annotation to allow the application owner to designate that my application owns components, right, as per my label selector, not only in my in my application's namespace, but also in these other namespace, in this other namespace or namespaces, to enable shared components to be reflected as part of the component list as well.
Okay, I do have one last question.
Yes.
So I see this is related to Cabanero.
Yes.
Is it a hard requirement, a soft requirement?
It's soft. The nature of the relationship is that Cabanero includes KApp nav as one of the components it installs. KAppNav has no dependency on Cabanero. But of course, you saw the shameless plug on our website pointing to Cabanero, which is another one of our open source projects.
Yeah, and the reason that I asked about it is Cabanero is OpenShift only at the moment.
Yes.
And it doesn't work on
True.
vanilla Kubernetes. And so I was
That's
curious
true.
whether this works on vanilla Kubernetes.
This does work on vanilla Kubernetes. We use Minikube as our litmus test for that, and that's one of our install environments, and that's documented on the KAppNav the KAppNav README. In fact, some of our developers only use Mini. Some of the guys that are working on KAppNav only do their development on Minikube.
Okay.
So this is, I have a quick question.
Sorry, was there another question? There's
Yeah, can you hear me? Am I coming through okay?
yes.
There's occasionally some static in there.
Okay, you're good right now.
Okay. Does this one of the things I and other developers hit up against a lot is trying to export our entire application definition. Like I've cobbled a bunch of stuff together. Let's say so I install a piece, then I install another piece using like apply, or maybe I'll use OC. Maybe I'll use OC new app, right? And put a bunch of new pieces into my namespace that are part of an application.
Yes.
Is there a way then to export that architecture and then import that into another Kubernetes cluster?
Well, that's a great question. So let me respond by first saying that has not been an explicit use case that we were trying to solve.
Okay.
However, in listening to you describe it, it occurs to me that that indirectly we may have created a way of doing that.
Okay.
So I mentioned that auto create capability. So it would be true that if you were doing what you just described, you create a deployment, you create some other resources. If let's say that one of the deployments that you created, you specified this auto create label, and then let's say that you just paid a little bit of attention to how you labeled the rest of the resources that you were adding. If you followed if you put the same label name and value on each of them, the result would be that you would have, with KAppNav installed, the result would be that an application CR had been created on your behalf, and that if you then dumped the definition for that, as YAML or JSON, whatever, through kube control get, you would have sort of the blueprint for your application, at least as to the extent that the application CRD, represents a blueprint. It doesn't in the sense, right, that it lists explicitly your resources, right? It does so by a label selector, but you'd have the application CR for your application built automatically. If you grabbed that and then toted that to some other cluster and installed it along with your app, you'd have a reconstruction of that which you had on the previous cluster.
Would it actually spin up all the things needed to recreate what I had on the other cluster?
Oh, I see what you're after. That's very interesting, but no, it doesn't at present do that.
Okay. And does the application CRD provide for that capability? And that's not just to you, that's just to the whole channel.
Right. So I'll let Matt respond to that. Be a function of the application controller. And as I pointed out earlier, we went our own way with that particular.
Actually, Janet may be better to answer this than me. Janet, are you there and paying attention?
Hey, would you state the question again?
So I'll state the use case, and then maybe the question will flow from that. I, as a developer, have put together an application in a namespace. It may be the entire namespace, it may be part of the namespace, but I used maybe OC new app, or maybe apply, I wrote some YAML, I did some stuff, I added a database, I added an app server, I defined that I needed some persistent volume claims. Basically, I defined the entire architecture of my application. If I define an application CRD for that, can I then export that CRD, bring that to a new namespace, and recreate the entire app that I had in my other namespace. Does that make sense? Does the CRD provide a mechanism for doing that?
Okay, so it's the custom resource based on the CRD. And I think, Janet, am I right saying that the answer is no? It gives you a description of the application. It gives the ability to query what's running, but it does not, the custom resource does not contain every other resource of everything that needs to be installed. So it doesn't contain all the details to recreate the deployments or stateful sets. You would need to export the custom resource for the application along with any other resources, deployments, stateful sets, things like that that you had running as well.
Yeah, that's correct.
So some feedback from an application developer, that's not that helpful to me then. The biggest problem I face right now is in dev, I create an architecture and I want to move that entire architecture to testing, or vice versa. Like my ops people create an architecture for me and I want to spin that up on my dev cluster so that I have the exact architecture. I don't know of anything that I've seen in the Kubernetes place that does that right now, and it's a pretty large gap.
Yep.
Yeah, if you want to move it from environment to environment, there are some tools that have been used that way. One of the examples is Helm.
Yeah.
Helm and Helm charts are used that way. You package it up in one way, and then you can move that same package from environment to environment or developer to developer.
Can you reverse engineer a Helm? Can like you export Helm on given point Helm at a namespace and say, hey, create a Helm chart off of this namespace?
No, but that sounds like a really awesome tool to build. I'm not.
No. I know. It's just funny. It's funny. That's all.
No. I actually think that that's a really good idea. So I'll take that back to the Helm folks. If you didn't know, I'm one of the Helm maintainers.
Okay.
And so I will definitely take that back because I think that is an awesome idea of being able to do that. I know people, and I think the Condé Nast folks, Katie, I'm not going to try to butcher her last name, gave a presentation on this at KubeCon this last November about how they are able to do some of this stuff. And so I know there are people out there doing what you're talking about, but they're not inspecting a namespace and then building a chart from that. But I do think that's a really neat and good idea.
Yeah, it was something that I've asked the OpenShift team for years, because it's something that I want to move between spaces. I want to recreate my entire app in a namespace, and it just and the way that developer features got prioritized, it never got prioritized, and so it's a gaping hole, I think, in the ecosystem from a developer's perspective.
Oh, you're absolutely right. As soon as you said it, I'm like, I want that. So.
Okay,
we'll see.
Thanks. So,
Thank you.
I didn't mean to derail. I just was trying to see if this tool could finally do what I've always wanted.
No, it was a great and relevant question. Appreciate the feedback. You're spot on.
Okay, so we do have other items on the agenda here, and I want to leave time for them. Are there any other questions about this?
I had one quick one. You mentioned rolling up the status of subcomponents of an app into the top level status of that app. Is there an easy way for me to control how that is done so that, for example, if we take the book info sample application for Istio, maybe I want to know if the ratings subcomponent is not working, but I don't want that not working to have my whole app indicated as not working. Can I say, like, this component is optional, report on it, but don't use it to calculate the status of the overall?
Gotcha. Yeah.
Okay.
Presently, no. There's a little bit of configurability around the status in terms of coloration and the status labeling, like the word normal. But we haven't taken it any further than that. The algorithm for the roll up is cooked in. So it's not currently possible to map that differently. That's an interesting use case.
Yeah, thank you.
Sure.
All right, my one suggestion for you is the CNCF has something called the SIG App Delivery. I don't know if you're familiar with it.
Not.
It's the CNCF has spun up several special interest groups that aren't for Kubernetes, but are there to support the TOC and the work of the TOC. evaluating projects, helping people understand the space, things like that. And one of the very first SIGs they created was something called SIG App Delivery. And I think this would be really good to share there as well to help them visualize and see the stuff in the space. They do overlap with us a little bit here, but they go into other places as well. They're really there to support the TOC and understanding the space more than developing a particular code base or to improve on things. But I think this would be a good place to show that off as well.
Okay. And Matt, what's the best way to reach folks over there?
If you go to GitHub/CNCF, there is a repository for SIG App Delivery that should have the information for it.
Perfect. Okay. I'll reach out to them. Thanks for the recommendation.
You're welcome.
All right. And thanks for the time, folks. Appreciate the feedback.
Thank you.
Thank you.
Yeah. All right. The next item we have here is add-on discovery. Do we have somebody to talk about that? I'm sorry. We're hearing lots of static. Hello? Sounds like we might have some audio problems here.
Hi, is that any better?
Much. Thank you.
Okay, great. So hi, I'm Evan Cordell. I'm from Red Hat, working on OpenShift and in particular the Operator Lifecycle Manager. Also on the call is Nick Hale, who's on the same team. We've been doing a bunch of work with the cluster add-ons group, and we've been looking at how to represent add-ons on a running cluster in Kubernetes. One of the things that has come out of that has been a little proof of concept project that we've been calling add-on discovery. It shares a lot of things in common with the SIG Apps application CRD and controller. And so we kind of just wanted to share it here, get some thoughts about where this fits with respect to the application CRD, and sort of just discuss how we can move forward, whether it should remain separate, whether we should work on combining them, or if there are opinions about our approach that that we should rethink. Does that sound like a good way to go forward?
Sounds great.
All right, cool. So I'm going to just go over some of the discussions we've had and then hand it off to Nick to do a quick demo. So let me share my screen really quick. All right, can we see that?
Yep.
Okay, cool. So this is going to be a little bit like a Twilight Zone version of looking at the application CRD. Pardon my cold. So one of the things that we're looking to define is how to sort of aggregate the status of an add-on in a cluster. So if you're not familiar, add-ons are typically things that are added to a cluster very early stage. So something like core DNS. And then the status of those components is typically really important. And it's also typically difficult to represent with a single like red and green color. Or I guess to tie it back to the last one, red, yellow, green. One of the things we're looking at is how do we take this set of resources that are all disparate. Every single add-on has different resources and different statuses, and how do we present those to a cluster administrator in a way that they can take actions on. So this is sort of the idea there. The basic approach is not is different in one big way from the SIG apps, the application CRD approach, in that users don't actually create these objects themselves. So this is also, interestingly, I didn't know this was going to happen, but also somewhat similar to the last demo, in that this label, or really this label prefix, is discovered on the cluster by the add-on discovery controller, and then it extracts the name from the label and creates add-on objects for you in the cluster, which means that in order to turn any set of resources into something that we think of as an add-on, all you need to do is add a label to all of your resources, and this just happens. So the two things that we do so far for this proof of concept is we collect up what objects make up the add-on. So in this example, a CRD, a deployment, and a, and a cluster role binding. And then we also aggregate the conditions that they have on each of those resources. So this can help actually discover what the status of the objects that you're looking at are. We have some ideas for some things we might look at in the future, And you can find those in the links that I put in the meeting notes. But so I think that's the general idea here, and I'm going to hand it off to Nick to actually do a quick demo of this, if he's on the call.
I am on the call. Zoom was just hiding from me. Let me go ahead and try to share. So can folks see this or hear me?
We can see it and hear you.
Okay, good. So I have a cluster with this running. Pretty much just a controller running. It is dynamically watching discovery and all new resources there. So like there's the caveat that like as you add new CRDs to the cluster, it will pick them up, but this could be kind of dangerous as the cluster grows large and new resource types are added. But part of what I did here was create that label on all of the resources that make up this particular controller. So it itself is listed on as an add-on to the cluster. If we take a look at it, we can see basically all the different components that make it up, and then it is again extracting that status conditions dynamically if it finds something under the status sub-resource that kind of matches this pattern and has these things, then it fills out the rest of the fields there. If I wanted to create some new thing, or perhaps add a node to add-on discovery for some reason, I could just label it there. If I wanted to create a new operator, let's say node discovery or something, node add-on, probably be better. I can do that. You can see that new add-on has been found. And even though it's a completely different type, it did pick up all of the conditions that are there. We can do something a little bit more complex. I actually have OLM here as a customization. And the only thing that it's doing is adding the label that is an OLM operator. It's more complicated. The operator lifecycle manager, the thing that we work on outside of this. So I can go ahead and, oops. Apply. So you can see if I have a sprawling application, this is probably a little small. I have a sprawling application like OLM. We can basically see all of the CRDs, the custom resources that make it up, the custom resource definitions that make it up, and even things that don't quite fit the conditions status pattern will make it in there in some way or another as long as they share some of the fields. So that's about it for the demo. It's pretty quick. Are there any questions we can help answer about this?
Does anybody else have questions? I do have a question to start. So the demo here was very command line driven. And you walk through creating some of the different things. Kind of where do you envision this, say 3 and 6 months? Because I see you're collecting metadata on the add-ons here. But what's the goal and how do you want to expose it or use it, things of that nature?
So I think one of the goals is to try and have a common way to talk about add-ons, controllers, operators. All these things look very similar, applications as well, with a similar language. And one of the roadblocks to that thus far has been getting everyone to agree to write a single object. And so this kind of makes it so that you don't have to agree to write a single object. You can come in and label things after the fact, and we can still do that. So we're looking at potentially using this as a way to represent operators. We're looking at using this as a way to represent add-ons for the cluster add-ons SIG and SIG cluster lifecycle. Potentially, this makes sense as a way to do, as like, this is kind of a question really. Does this make sense as a part of the application controller, as like another option for how you build application objects, that type of thing?
I don't know, from my take, I'm not entirely sure yet. And part of it is, and this will get into just some of my thinking, application developers and application operators are just a different user context from cluster admins. And granted, some people will fill all of those roles, but quite often you may even have just 3 entirely different people with different backgrounds and different needs. And I'm not sure how the base level metadata and its collection and interaction and what information needs to bubble up to fulfill those different needs. And that's my fancy way of saying is I just don't know. I think there's probably a lot of shared code and ideas, but I'm also not sure. I want to keep the door open for conversations, but I don't know if that means merging them or sharing a library of code and having differences or what that means. But it is worth having that continued conversation.
Yeah, that's a good thought. I appreciate that.
I'm sorry, what was that?
I'm just saying I appreciate that thought.
Yeah. And that's why. On our side, Janet, who's mostly driving the application CRD work these days? Is that you?
I think it's me, Ken, Barney, Orton.
So those are the folks from this side who would probably be most interested in talking about those things.
Okay, maybe we can have another conversation about that.
Yeah, that sounds good.
It sounds good. Thank you, Janet. Okay. So that's what we've got on that. I think the only other item we had real quick, do folks have any other questions about this? I'm gonna take silence as nothing. All right, so thank you for that presentation, and I look forward to us following up more and having some more conversations on it. The one last item was and I edited this was a last minute thing that came in this morning. There is a flaky issue, although Maciej said he was going to get on it first thing in his morning, but we do have a flaky issue, a test flake in Kubernetes that was reported to us as part of cronjob. So that was it. Did anybody have anything else?
Hello, this is Nan from Google. I'm on the same team as Janet and Morton. I just want to give a heads up. We are currently working on promoting cronjob to GA. Right now, we just started on a design doc. Once it is ready, we will share it with all of us and collect feedback. That's it.
Thank you. When the design doc goes up, it will need to be an enhancement on the Kubernetes enhancements repo?
Yes, definitely.
Okay, fantastic. I look forward to seeing that.
Okay, thanks.
All right, is there anything else? Everyone, have a wonderful next 4 weeks because we are off in 2 weeks due to the holidays, and we will be back on again, talking again in January. Have a wonderful holiday season, folks.